Hi, my name is Engber, and I'm with the National Park Service, and today I'm going to be discussing prescribed fire for conifer management in oak woodlands, a guide to meeting objectives in Northwest California oak woodlands and grasslands. With that, we'll go ahead and get started. So my presentation outline, today we will be talking about a context for conifer management in North Coast oak woodlands and grasslands. Then I'll get into prescribed fire as a management tool. I'll discuss burn objectives, seasonality and timing, example burn prescriptions, fire effects on conifers and mechanisms of mortality, briefly hit on fire effects on oaks. I'll cover fire return intervals, and then I will discuss mechanical methods and some helpful tools, links, and apps. So I work in Northwestern California. On the right, this is a picture of an Oregon white oak woodland that we burned in the fall of 2018 for the primary objective of reducing encroaching Douglas fir conifers. Just to give some context, oak woodland landscapes are highly valuable, especially in Northwestern California. They tend to occur in these conifer-dominated landscapes as openings. And so because of that, they provide a huge amount of forage value. They provide acorns, an amazing amount of understory plant diversity in terms of herbaceous species, grasses, wildflowers, a unique wildlife habitat for elk and deer, grassland bird species, and a lot of economic value as well that the adjacent coniferous forests do not provide. One of the primary issues we deal with in our oak woodlands in Northern California and really into the Pacific Northwest is that Douglas fir rapidly seeds into these woodlands, both Oregon white oak and black oak, as well as open grasslands. And they're a prolific seeder. They tend to occur adjacent to these oak woodland environments. And this is an example of a picture that was taken in 2018 in a woodland that was burned in 2008. So about a decade of conifer growth. This is from Redwood National Park, and there was an adjacent conifer stand, but rapid encroachment of Douglas fir in this environment. Over time, if you don't do any management in terms of burning or cutting, eventually you'll lose that understory grass component. And you can see an example here on the right of a heavily encroached oak woodland. And ultimately, you're going to lose your oaks as well because the fir grow much taller, they cast a huge amount of shade, and the oak crowns will initially recede, slow their growth rate, stop acorn production or slow acorn production, and ultimately they will senesce. So the main topic today is talking about prescribed fire as a management tool to address this conifer encroachment issue in our oak woodlands and grasslands. And these oak woodland landscapes require frequent fire. We've used fire for maintenance of mechanically treated areas and intact oak woodlands, so with low amounts of conifer encroachment, just maintenance phase really. We've used it for restoration of woodlands with young encroachment, so perhaps conifers under about 6 feet tall, and we'll talk more about that later. And then we've used fire on about a 3 to 5 year interval, depending on the site and the proximity to the conifer seed source. In Northwestern California, if you go more than about a decade between fires and you have adjacent conifer stands that are continually seeding into your oak woodlands or grasslands, you may not be able to achieve objectives in killing those fir due to their size on that decadal interval. So now we'll discuss burn objectives. I'm a fan of writing good burn objectives that are specific and measurable. Specific objectives should be developed to enable the burn prescription, burn unit prep, and burn implementation to support your objectives. Sometimes I hear people saying, well, we're just burning to burn because fire is good, i.e. burning for black acres without regard to quality, and that may have unintended consequences and also just present limited opportunities for learning, improving, honing in on your prescription, and rewriting your objectives, so adaptive management. So for example, you might have an objective that says reduce the overall density of conifers by 90% by scorching at least 50% of the live crowns of individual trees. And so in this example, you can see that we have actually a couple burns represented here with some dead standing that was for saplings. But you can see crown scorch on these individual trees. That's something that can be assessed. We know that there are thresholds for mortality with crown scorch, and it's something that's measurable. So now I want to talk about seasonality. So typically in our oak woodlands, we have a fall season with isolated winter and sometimes spring windows during prolonged dry spells. And it just depends on the winter, but typically we will have 1 to 2 week dry spells in December, January, February in northwestern California, and those can be good opportunities to get into your oak woodlands and grasslands in exposed locations. So this chart, I've got just months on the left. So in northwestern California, typically the fall prescribed fire season begins in September and October. So for most of your oak woodlands and grasslands, during this time, wildfire season's coming to an end, and we start to get into those fall burn windows in terms of weather. Pre-rainfall is ideal at this time, or just minimal rainfall, perhaps less than a ½ inch or so. You got to let it dry out after that. But you're going to have limited success after wetting rains. It takes a while to dry just because the canopy is still intact. There's not a lot of leaf litter on the ground in this early September and October phase. So you really want to be getting in there before you have significant wetting rains. Otherwise, you're going to have to let those areas dry out for some time. Into November and December, those canopies are going to start dropping more of the leaves, so there'll be a little more sun exposure on the ground. You'll have more leaf litter building up, but you're going to start losing your window for your north aspects, east aspects, areas with a lot of Douglas fir encroachment later in the fall and that early winter period. But, however, your south and west aspects are going to be more favorable. You'll have good windows during those 1 to 2 week dry spells for those south and west aspects. So don't give up after rain, because they may come back into prescription in December, January, and maybe even into February. But you need a good 3-4 day minimum drying period. In your grasslands, you've got a little bit more flexibility there. Pre-rainfall is ideal in that September-October period, but they will dry out after usually a minimum of 3 days of sunny weather, breezy weather. More coastal sites may green up sooner if they're not getting frosted every night, but winter windows are also going to be an option during your dry years. Dry days with some wind may be required to meet objectives if you've had a significant amount of green up, so say maybe 6-8 inches of green up, but I've still seen successful burns with high levels of conifer mortality or coyote brush, for example, when you have a breeze during those winter windows. But you do need about 3 days of sun minimum to dry out those grasslands following a wetting rain. Lastly, there's some late spring windows that you might want to utilize if you're trying to reduce invasive species such as star thistle or medusa head. In northwestern California, the Humboldt County Prescribed Burn Association has had some success utilizing those early summer or late spring windows to reduce the cover of star thistle and medusa head. It's a fairly narrow window, and you're right on the shoulders of fire season, so you may or may not get that window every year. So prescription, this is a major component of burn planning and prescribed fire, and so for federal managers, we have to follow the NWCG PMS 484 Interagency Prescribed Fire Planning and Implementation Procedures Guide to develop our burn plans. For private lands managers, you just have to follow CAL FIRE policy and their current requirements that they set out. I do recommend utilizing a burn plan. This will ensure the prescription will meet both your resource objectives, which is what I'm discussing in this presentation in terms of meeting your objectives for killing encroaching conifers, but also meeting your operational burn objectives, which is keeping your fire within your unit. So the first thing on prescription is that each site is unique and will require a prescription that's based on the specific fuels, the slope and aspect, local winds, canopy cover of oaks and conifers, presence of control features, unique features within the unit, or potential resource availability for your burn. In other words, just don't use a cookie cutter approach, because in oak woodland on the north slope, for example, or with a high coverage of conifers, may need to be burned early in that fall season when it's dry, because it may not dry out well later in the winter, versus those south and westerly exposed aspects that you may have a longer burn window in. So develop the plan and the prescription specifically for each unit. One tool I like to use is the probability of ignition, PIG or POI. It can help you interpret what the various relative humidity, or RH, and temperature scenarios mean. So for example, with the POI below 30%, fire spread becomes challenging in shaded fuels. So that means that approximately 30%, or 30 out of 100 embers, for example, would start and spread a new fire. If your POI is greater than 60%, generally that's a threshold beyond which any spot fires are likely to become established and spread and be problematic for you. But the POI, it's a combination of RH and temperature, time of year, and it can be pretty helpful in understanding what the fire behavior is going to be doing. So for example, if you're burning early in the fall season, so September, October, prior to significant fall rains, you might want to manage the shaded probability of ignition at 30% or more for the oak understory. I've observed when you're down in the 20% or lower, you tend to not get fire spread under that oak canopy, especially early in the season when there's not a lot of leaf litter availability. So generally your RH window is going to be 25 to 40% and temps around 65 to 80 to get into that 30% probability of ignition. I do have another presentation on fire weather if you're not familiar with how to calculate the POI. So those early season days may be your only window for north and east aspects or areas with large conifers intermixed that will not dry well following rain. 10-hour fuel sticks are another great indicator for the oak understory. Generally a range between 8 and 13% will carry fire well in oak woodlands. Less favorable aspects and wind protected sites will require the drier scenario to meet objectives. So if you're coming off a rain or you're in an area that's more shaded, you're going to want to be closer to the 8 to 10% range to make sure you get good fire spread and fuel consumption in your oak understory. So many of the North Coast oak woodlands and grasslands are bounded by coniferous forest. Use this to your advantage. Conifer forest can serve as a control line or an unburnable area after rain. So in November, December, January, typically we don't get dry spells that are long enough and dry enough to dry out that fuel model 8 Doug fir compact litter. And so you can utilize that to your advantage by using it as fire line essentially. So you can focus on exposed south and west aspects. Just make sure that you test fire in the conifer forest initially to make sure it won't carry. But these are areas where you may be able to burn hundreds of acres in oak woodlands and grasslands with conifer forest as fire line, which can be really efficient in terms of the amount of fuels prep you need to do. So I have an example burn prescription here that has a hot end of the prescription and a cool end of the prescription. And really a broad range of conditions can allow for resource objectives to be met under a range of seasonal conditions. So if burning after wetting rains, the hot end of the prescription will better meet your objectives. If burning pre-rain in early fall, you have a little bit more flexibility in the prescription, but remember to keep that shaded probability of ignition around 30%. Generally, a little more wind can compensate for cool conditions in this fuel type. So for example, if you're after rain in November, and you're on the cool end of the prescription in an after rain scenario, it's probably not going to burn all that well. You're going to want to find a pretty dry day versus if you're earlier in the season when the days are longer and you're coming off that summer drought period. If you're right on the hot end of the prescription at that time, you're probably going to be creating a lot of scorch in your conifers, but you may also be consuming every log or stump, and you may be scorching the oaks as well. So this is a good range for meeting objectives across that spectrum of seasonality, and you just want to be within here depending on where you're at following rain events and cool periods and things like that. Specifically the components, I did add 10-hour fuel stick moistures in here as well as that probability of ignition as mentioned. Pay attention to those. They're responsive to the relative humidity and the temperature, and so if you can use 10-hour sticks and POI, you'll have a pretty good idea of how the fire is going to burn and what kind of fuel consumption you're going to get. So shifting gears a little bit, I want to talk about fire effects on conifers and actual mechanisms of mortality. And so Generally, there's two ways you can kill conifers, and they're often correlated with each other for small trees. But the first is through scorching the crown. And so on this image on the left, you can see an area with crown scorch and consumption in the black and red here, and then live crown above. So we refer to this as the percent crown volume scorched, and it might be, I don't know, 60 or 70% scorched in this image. And then you can injure conifers through basal injury. So these are some conifers that I peeled, some Doug fir saplings, and you can see the areas of cambial mortality down below and living cambium above. This is what the bark looks like, where it's scorched and green on one side. So there's different types of ignition sequences you can use depending on your fuels to injure conifers in these two different ways. So for example, if you're in open grass, you want to shoot for about 50% crown scorch or more. So using head fires and open grasslands can be effective. Up to about 6-foot height conifers, occasionally you can get maybe up to 10-foot height, but it's pretty intermittent in terms of killing those size classes. You tend to have more success meeting that 50% crown scorch threshold on the 6-footers. In oak understory with deep leaf litter, backing or flanking fire may be as effective or more due to the longer residence time, but you've got to have that deep leaf litter present. It's got to be dry, and that way you may be able to girdle those trees, maybe 2 to 3 foot conifers due to that residence time around the base. So if you're in oak woodlands with a deep leaf litter layer and the fire's backing and flanking well, that might be the ticket to achieving your mortality objectives. And I mentioned this, but larger conifers that are greater than 8 to 10 feet tall, they can be torched in grass if it's dry and you have a bit of a breeze, but these often require mechanical removal. It's just hit or miss whether you can get those with the burn. And usually multiple burns are required. If you can get them all in one, that's great. But if you're burning on that 3 to 5 year interval, like I mentioned earlier, you're likely to be able to pick up additional conifer mortality like we see here, where we've scorched a couple of these, probably to the threshold. Some of these may need to be cut down. And then you can see the dead conifers from the initial burn, which was about 5 years prior. If you're going more than 10 years between burns, in the North Coast anyway, you're likely to get conifers that are above the size class that you can kill easily with fire. Just another image of that's what you want to see, just about 100% mortality and 100% crown scorch in those small conifers. Did want to hit on when to cut versus burn. It behooves us as managers and landowners to use fire frequently, because if your conifers get beyond this establishment period and they start getting into the crowns of the oaks, overtopping the oaks, or ultimately converting to Doug fir forest, the input in terms of your restoration and maintenance energy just goes up across the scale. And burning is efficient. You can cover a lot of ground quickly, but it's really only effective for those smaller size classes of trees during our typical fall and winter burn windows, when conditions are relatively cool compared to the summer period when wildfires are burning, but we're not using prescribed fire. So once you get into this piercing phase, just understand you're going to be getting into the mechanical methods, and they're more expensive and require more energy input to get back to that maintenance phase. You can get creative with larger trees. So I've built piles around larger Douglas fir to girdle them when you burn them. It doesn't really add any more cost to your treatment when you're doing a mechanical removal, and it's an efficient way to girdle some of these trees with fire. We also use girdling quite a bit, and one thing that's maybe just more fun than anything else, but actually lighting those girdles a year or so after, it'll look cool, and it'll ensure that any of those areas of cambium that have healed over get cooked. So I did want to mention the fire effects on young white oaks. So I've done some small studies in oak woodlands, and I've looked at small oak saplings about 5 to 8 feet in height. And I found that these are pretty easily top killed during fall prescribed fire windows. So this was a burn we did in October. And I think I tagged close to 60 individual oak clumps, And this is the photo sequence. You can see pre-burn in 2016 in the summer. So the grass layer, these are probably 5-foot oaks, grass layers maybe 2 to 3 foot tall. Pretty clean burn in this site. This is the same clump of oaks. And then 1 year later, you can see they were top killed, and then there's a resprout that's about maybe 2 feet tall in this photo. And so what I found is that most oaks in this size class, so maybe less than an inch diameter at the base and under about 8 feet tall, in that multi-stemmed shrub form, are very sensitive to top killing. Most of them are going to resprout, however. The sprouts grow pretty quickly depending on browse pressure. But if you have a concern about oak retention, you're trying to regenerate oaks or recruit more into the canopy, and you have them in this size class, you should consider weed-eating fuels around those or pulling fuels back, whatever your fuel type is. But you're probably going to need to do some kind of mitigation if you're trying to recruit those, because if you're burning on that 3 to 5 year interval, they tend to get top filled almost every time you burn. So helpful tools, I've hit on some of these, but 10R fuel sticks, they're 1/2-inch ponderosa pine dowels. These are just an effective way to help you understand how things are going to burn in the understory of an oak woodland based on the percent moisture content. So they're standardized to 100 grams. You use a field scale, you go out, weigh them, and you can figure out what their percentage is. You want to keep them clean and don't touch them with your bare hands. And yeah, just a convenient tool. Once you start using these in multiple burns, you'll get an idea for what those good ranges are and help build your prescription. As I said, about 8 would be on the dry end for our fall burn windows, and up to maybe about 13%, and you're getting on the wet end at that point. But really helpful tool to let you know when you're in prescription. Another tool I like to use for calculating the probability of ignition as well as other weather metrics for fire weather is the Kestrel 5500 Fire Weather Pro. So this one, there are other Kestrels that give you the basics but don't give you the fine dead fuel moisture or the probability of ignition. It's pretty convenient because you can set these up on a weather station. They'll data log on a tripod, I should say, and you can put them out there for a whole summer even. They've got a lot of capacity. And then you can Bluetooth transfer to your mobile device through an app in the field, and it'll plot out your fuel moisture values. And then you can also just use them on burns for calculating the probability of ignition, for example, and fine dead fuel moisture. So pretty convenient, or you can do it the old school way, using a sling psychrometer, dry bulb, wet bulb, and then going through the RH tables, the fine dead fuel moisture table, and ultimately the probability of ignition table. You should also be familiar with the Meso West site with the RAWS weather stations. These are remote automated weather stations used for calculating fire danger indices. And you can see there's a pretty good distribution, pretty good network. So you can go and find the nearest RAW station and just keep track of those hourly weather measurements throughout the summer and into the fall to make sure that you're getting in prescription. If you're not familiar with RAW sites, get familiar with it. Really good tool for those of us in prescribed fire management. Lastly, I just wanted to mention an app that I like that's called the Wildland Toolkit I came across. It isn't free. It's about $5. But this one you can put in your relative humidity and temperature, and it will calculate fine dead fuel moisture, probability of ignition, as well as fire behavior. And it has a bunch of other useful tools in it, but it's one of the more convenient apps I've seen for fire weather calculations. So check that one out if you get a chance as well. All right, that's all I got. Get in touch with me. I'm Engber, fire ecologist at Redwood National Park. Get in touch if you have questions. Thanks.